All right, so we're going to look now at our compound interest formula, but what happens if we compound something continuously? So we have our compound interest of A equals T times 1 plus R over N to the NT. So that's where we're going to start, but we're going to end at another formula of what happens when we can compound something continuously. Now this does have to do with our E number that we found the other day. So we're going to use a little algebra to help manipulate this equation. So I'm going to say let x equal n over r. Now I'm just going to use x as a way to substitute, and this will help me to solve. So x equals n over r. Now I can use a little algebra to manipulate this. So one thing I could do is multiply both sides by r. So I can say x times r equals n. Now I haven't done anything outside of the ordinary. All I did is multiply by r on both sides. Another thing I could do with this is I could keep going. I could divide both sides by x. And I get r equals n over x. And I could divide both sides by n. So n's currently on top. I could divide both sides by n. And I would end up with, these n's would cancel on the right side. And when those cancel, they would end up with 1 over x on the right side. So I get r over n equals 1 over x. Now, all I've done is just some algebra manipulations and saying that x equals n over r. Now, I'm going to use that to help me to actually solve this, okay? So instead of having r over n, I'm going to replace that with what I've got over here. So r over n is equal to 1 over x. So I'm going to replace this. So I will have a equals p times 1 plus 1 over x. And then I'm also going to replace this n up here with what n equals here. I'll put it in a different color for you. I'm going to replace this with this, and I'm going to replace that with that. Okay? So my exponent then changes to x times r times t. That's an r. All right, so now all we've done is substitute. We've plugged in different values that are equivalent. Now I'm going to take this apart a little bit. I know I have a, p, and I just want to focus on the 1 plus 1 over x to the x. And then I'll multiply it by the r, or raise it to the r times t. Now remember, when we were solving for e, what we were doing is we were taking this denominator and this exponent, and we kept making them larger and larger and larger, right? And we ended up getting to this number of e. So what we're going to look at here is what happens if we compound something and we compound it continuously. So we could say that our n, so as n goes to infinity, then we're really meaning that x would approach infinity. So as we're compounding this continuously, as we are continuously getting interest, then what happens on the inside here of these brackets is that really this becomes the same as what we saw on the page before. So as our 1 plus 1 over x to the x, as that gets larger and larger and larger, we know that we become the letter E, which is actually a number. So as that goes to infinity, then this part in the brackets actually becomes E. So we get a new formula that's A equals P E to the RT. So notice how that's a T. The R and the T, they stay there as exponents. Just the part in the bracket became the E. And remember that E is a number. So here, our A is still the ending amount. The P is still the principal. The R is our interest rate. Our T is still our time in years. But now we have a new formula for when we're compounding continuously. So let's write that out. So compound continuously. When we do that, we use our new formula, which usually people refer to then as PERT. So put a box around that, and then we will use that in the upcoming days.